Alright, so in this video we're talking about the angle bisectors of a triangle, and pretty much since we have three angles in a triangle, then we have three angle bisectors of a triangle. And the three angle bisectors of a triangle are always going to meet up or be concurrent at a point P, and that point P is always going to be on the inside of our triangle. So the angle bisectors are always concurrent at a point that is inside of a triangle, no matter what type of triangle you have. This point of concurrency, point P, is called the incenter of the triangle. So when I say the word incenter, we're talking about angle bisectors, which are these blue lines in this picture. And what we know about the angle bisectors of the triangle is that they intersect at a point that is equidistant from the sides of the triangle. So this point P is the same distance from each side of the triangle since it's the incenter. So PF is congruent to PD, is congruent to PE. These three sides, so point P is the exact same distance from each side of the triangle because it's an incenter. Again, incenter means an angle bisector. Now let's use that information and do an example. We're told that the angle bisectors of triangle MNP meet at the incenter, which is point L. In part A, we want to know what segments are congruent. Alright, well, since point L is the incenter, we were just told that point L, the incenter, is always the exact same distance from the sides of the triangle. So these three sides are congruent. We know that since point L is an incenter. So we have that LR is congruent to LS is congruent to LQ. Again, point L is an incenter, which means L is the exact same distance from all three sides of the triangle. Now we want to find the distance LQ and LR. Alright, well, we want to find LQ, which is this distance right here, and we want to find LR, which is this distance right here. To help me do that, I'm going to first look at the information I'm given. I'm looking at this triangle right here. Well, I notice right here, this is 90 degrees, and I have a straight line. So that means straight line is 180. Since this was 90, that means this has to be 90. Okay? So I want to redraw that red triangle to make it a little bit easier to see, and this is a smart trick to do. Okay? And so we know the short side was LQ. Okay, and that's one of the sides that I was trying to find. We know that the hypotenuse, based on our diagram, is always directly across from the 90-degree marker, and that was 17. And we know that this side was 15. So now what we can do is do Pythagorean theorem. This is going to be our C, I'm going to call this A, and this side I'm trying to find is going to be. So I have A squared plus B squared equals C squared. Plug in what I know. 15 squared plus B squared equals 17 squared. And these numbers are pretty big, so I'm just going to use my calculator. I think 15 squared is 225, but I want to double check. Good. 225 plus B squared equals 17 squared. I think that's 289. Yes. Alright, so now I want to solve for B squared. So I'm going to subtract 225 on both sides. Oops. 225. Cancel out, so B squared is equal to 289 minus 225, so 54, I think. Let's use calculator, double check. 64, so I was close, but not close enough. Alright, but I want to figure out what B is. So I'm going to take the square root on both sides, so B is going to be 8. So since LQ is 8, and we know that LQ is congruent to LR, that means LR also has to be 8. So both of these sides are 8. And that's it for this video. Again, just use the properties. Yes, the picture was pretty complicated, but what I did was draw that triangle that I was working with out separately, so it was a little bit easier to see and work with. That's a good strategy to do. As always, let me know if you need help.